Hey everybody, hope you're all well. It's going to be a Commodore 64 PLA related video today. A little while ago I did a video on these Atmel 512 45 nanosecond PLA replacements. I shamelessly copied Gadget UK's video and I just shoved them in 5 different machines, put different capacitors on it, pretty lumpy. Came to the conclusion that they can work, with a bit finessing they can work. Wasn't very scientific. This is going to be a more scientific approach. I'll link a video in the description, but a video by MindFlareRetro outlines this test where you use a 74LS279 set reset latch and you connect it, it's supposed to be to the cartridge port, but I haven't got a cartridge, so I've just wired it straight to the computer. And what this thing does is it sits, these two lines come straight from the PLA, ROM-H and ROM-L. When you turn the machine on, they should go low once to check for a cartridge. If you reset it and they ever go low again, you've got a glitch on the PLA. So I'm going to be making up one of these circuits, attaching it to a test rig, and then testing out these various types of chips. So start off with the original EPROM PLA, and that may be a carrier board like this, and then we'll move on to these. Now these, in that video, as Latch, the guy who makes the Plankton, which is excellent incidentally, mentions these chips. Says the supply's dried up, but if you can find genuine ones, they're drop in, subject to being adapted. M27C51290B6. Supposed to have exactly the same characteristics that make them suitable for not needing any filtering as a PLA. So I got all excited, I bought loads of them. Next up, I've got a flaky genuine PLA. We'll see if that glitches the test rig. That's the one that was giving me dodgy graphics. Then I've got a genuine PLS 100N. These are the chips that Commodore copied to make the PLA. They're eBay purchased, they've been pre-programmed, they just drop in straight away. And then to top it all off, we've got this. This is my take on an adapter, which I've just made out of resistor legs and what have you. And what this is doing is it's taking the original PLA EPROM, the 45 nanosecond chip, but instead of just putting a capacitor on the CASRAM line, it's putting resistors and capacitors on each of the data lines. So same chip, just a different set of filtering. And that is linked on Ray Carlsen's webpage. He's updated his webpage. I'll link that in the description, how to make one of those. And that's what this is here. If you're wondering what that is, that's what that is. So without further ado, I'm going to show you me knocking up the circuit here. This circuit, attaching it to the back of the computer. I haven't got a cartridge, so that's how I'm going to have to do it. And then it's literally going to be one of these in and testing whether we get a glitch. I'm just going to run a game or a memory test or something. That's the circuit. It's just got a little switch on it here to reset it. It's normally open, the switch. Just a little resistor there, LED, and red is power, which is 5 volts. Blue is ground. And then I've got the ROM high and the ROM low. I've done this yellow and green. Okay, so we're back here on the long-suffering C64 test bench. And what I've done is I've just buzzed out from the PLA. This is the PLA here, believe it or not. And I've buzzed that out to the cartridge port, because ROM-H and ROM-L go all the way from the PLA directly to the cartridge port. And what I've come up with is that. So this one here is ROM-H, this one here is ROM-L. These two here are ground, and these two here, one in, these two here are 5 volts. So I'll test that before I power it up. All I'm going to do now is solder some wires, solder some wires onto there, and then run them out the back. Okay, so first of all, we'll try the old EPROM PLA. That's just a 512 45 nanosecond with just the CASRAM capacitor. Turn it on, and it appears to work. You can see Commodore, I don't know if you can see it there, but it does say Commodore, but it keeps going low. I reset it and it keeps going low. You can see the light there, so that suggests that while it works and it lets me type stuff, is not the best. So let's try the Ray Carlsen solution. Okay, this is the Ray Carlsen solution, the one with the very long legs. Let's see what that happens there. Let's just plug it in. Comes up. I reset it and it stays off. Hopefully you can see that, but it stayed off. It's not coming back on at all. Just going to load a game or something. Still not glitching. And it's still not glitching. Try another game of it. I don't know. Still hasn't glitched. And there we go. And we'll call that a success for the Ray Carlsen job. And next up, let's try the 90B6L. Come on once, reset it. It's not glitching. Still not glitching. Still no glitching. Try a different game, so reset it. Turn it back on. Ah, the light didn't come back on. Now why is that? Turn it off. Now the light comes back on. Maybe there's some stray capacitance there or something, I don't know. Reset it. Still doesn't appear to be glitching. Do one more test. See, that light didn't come back on again. Let's just see. Let the power drain out a bit. No. That's bizarre. There's something weird going on there. Now it did. I think that's just stray capacitance. It's just checking the memory. It passed. So that looks okay, subject to the fact that sometimes the light doesn't come on straight away. Okay, next up we've got a genuine MOS PLA, but a flaky one. See how that fares. Turn it on, the light goes on. Turn it out. Lights come back on. Give it another chance. Turn it on. Yeah, the lights come back on. So it looks like the memory test is a pretty good giveaway. And the lights come back on again. So that PLA, although it's genuine, is flaky. So next up we've got the new old stock PLS100Ns. I know for a fact one of these works, one of them doesn't. I've contacted the vendor, he's going to send me a new replacement. But I'm going to show you the one that works, because I think there was a programming error made on the one that doesn't. And I'm just going to run the memory test because that seems to throw it the most. Passed. Turn it off. So that's working. Let's try something else. Yeah, so pretty conclusive, that's working. I think this machine's had enough abuse. I've put its own PLA back in. Make sure that's okay. Let's do the mem test. So it passed. So that's enough abuse for this machine. Let's go and do some conclusions. Okay, so where does that leave us? Well, the original 45 nanosecond chip doesn't work very well, or it glitches with just the CASRAM capacitor. However, it can be made to work a la Carlsen, and I need to make up some proper boards for that. Incidentally, MindFlareRetro's replacement board could probably be quite easily modified to accommodate these components. So that is a goer. These 90B6, I'm not convinced. The reason I'm not convinced is sometimes when I reset the computer the light doesn't come on. It's not checking the cartridge port, so it might be glitching. They're good enough, but what I think I would be tempted to do is to put one of these onto one of these carrier boards and see if it improves the situation. But certainly usable, not showing any other symptoms of trickery. The flaky PLA, that was from another video that was showing me crap graphics. That obviously was the cause because it showed up with the test, so the test does show it. And the PLS100Ns, well, if they're good, they work perfect, but this one in particular has got to be sent back to the vendor because it doesn't work. So, well, it does work, but it's glitching. So that is my little conclusion from my little slightly more scientific test of PLA substitutes. One thing I would say is all of these, you know, if you like messing around with stuff, great. If you like doing this kind of thing, great, like I do, great. But really, 15 quid just going by Plankton. It's much more, you know, reliable, you know, less power consumption, more thought out. But if you like rolling your own, so to speak, then I hope you found that useful. Thanks for watching. Take care. I'll see you all later. Cheers. Bye.